So the last of our conic sections is the hyperbola. So let's take a look at what we can see about the hyperbola from current slide. So the hyperbola drawn here is really only shown in blue. You've got two branches of a parabola that face away from each other, and in between we've drawn all this other stuff. Now the purpose for drawing all this other stuff is kind of like scaffolding. It's helping to draw our hyperbola. What we want to avoid in graphing a hyperbola is actually having to plot points individually. That's a real pain. So what we're going to do is we're going to plot 4 points as if they were an ellipse, join those 4 points with a rectangle, and then the diagonals of the rectangle are going to be the asymptotes. So where would you see the shape of a hyperbola? Well, a nuclear cooling tower is a hyperbola that's been rotated around an axis. And what that allows you to do is have the maximum uptake of air over a cooling pond, and then as that air rises, it rushes up. Eventually it starts to cool and lose its energy, so you fan out near the top. LORAN is the system that was replaced by GPS, but you used to find where you were on the Earth by a system of beacons that would emit a signal, and you would find the intersection of two of those signals to figure out where you were. When a jet travels faster than the speed of sound, it leaves behind a sonic boom that'll intersect the ground at one branch of a hyperbola. I always thought this was a cool picture. The actual moment that you break the sound barrier. Just really cool. Dulles Airport in Washington has a roof in the shape of a branch of a hyperbola. Kobe Tower, again, shaped of a hyperbola rotated around an axis. And I don't know about this one. This is again at that science center from our work on ellipses. I don't know if that's a hyperboloid or not, but it's kind of cool. Anyways, let's work on graphing hyperbolas. So let's get rid of that and back over to here. Section 11.3. We'll start with problem number 14. 9x squared minus 4y squared equals 36. Much like what we did with, is that not the right equation?
That's number 17.
It's number 17? I'm sorry, I'm doing one of your homework problems. You know, I think what I accidentally did is I probably grabbed, I was looking at the wrong book when I grabbed your homework problems, or the problems I was going to demo in class. Okay, so I'm doing one of your homework problems. Please forgive me. We're going to do the same thing here, though, that we did with ellipses, and that is get a 1 on the right-hand side. So let me divide everything through by 36, and I'll get x squared over 4 minus y squared over 9 equals 1. You can probably bet that I'll rearrange that a little bit further. What else do you suppose I could do on this one? Thank you. So 2 squared and 3 squared. All right, that looks nice. Now, as far as graphing is concerned, we're going to treat this as if it were an ellipse. So we're going to plot some points as if it were an ellipse. Now, where would those points be? How far would I have to move in the x direction to find those points? 2, right? 2 to the left and 2 to the right. And then in the y direction, up 3 and down 3. So up 3 and down 3. So there's my 4 points, but I'm not going to draw an ellipse. In fact, how come this isn't an ellipse? What's different about this equation as opposed to our ellipses? You have a minus. So if there's a minus between these things, when you have it in the standard form, then it's a hyperbola. Now, I can't emphasize this enough. If you screw that up and draw an ellipse as opposed to hyperbola, there's not a lot I can do about partial credit. you're going to get hammered on that one. You're going to get 2 points out of 7. So make sure that you graph a hyperbola here. Now, let's play connect the dots. And when we play connect the dots, the next thing that you would typically have to do is draw the diagonals. Well, in this first one, the diagonals are drawn for you. So, okay, great. We still haven't drawn our hyperbola yet. Our hyperbola is going to be two branches of a parabola that face away from each other. Now the question is it going to open left or right or up and down? It depends on which one of these terms is the positive term. But when you have it in this standard form, if the x squared term is the positive term, then it's going to open left and right. Left/right. If the y squared term is the positive one, it's going to open where? Up and down. Good. So in this case, we have a hyperbola that opens left and right. One thing that I would ask is that you do a reasonable job of trying to get close to this. So there is one branch, and I'm going to kind of move this around for my convenience and draw the other branch. So something like that. So, okay. Now there's, as you can probably imagine, there's one last little characteristic we need to take care of in terms of graphing this, and that is find the foci. So the foci are going to lie inside each branch of the hyperbola. And the equation for the foci is going to look pretty familiar, but it's going to be a little bit different. We're going to want to calculate c squared equals a squared plus b squared. Now, how is that familiar? How is it different? Yeah. Good. Same terms, different signs. It's a plus. Now, in this case, it's going to be c squared equals 2 squared plus 3 squared. So c equals plus or minus the square root of 13. All right, square root of 13. Want to give me a numerical value on that? All right, so about 3.6. Now the only reason I calculate the 3.6 is because I wouldn't know where to graph that otherwise. So 3.6, about here. So square root of 13 and 0, and negative square root of 13 and 0. There and there. Those are the foci. Now, you can tell if you made a mistake. It's very easy to get this confused with your formula for an ellipse. So suppose that you accidentally calculated this as if it were an ellipse. So you did c squared equals 3 squared minus 2 squared. You get c equals plus or minus the square root of 5. Square root of 5 is about 2.2. Well, actually, in this case, you'd be all right. But a lot of times, when you try and plot that, you'll find that your foci is actually inside of this box. It shouldn't be. It better be inside each branch of the hyperbola. So, in this case, it wouldn't tell you, but sometimes you will get some feedback on that. How are we looking with problem number 14? All right, let me make a couple comments then about the graph. And I'm just going to draw another one of these. There's a couple things, a couple common errors in terms of drawing the graph. So sometimes People are a little bit too conscious of the fact that this is an asymptote and that the graph is supposed to follow along the asymptote. So they'll draw a hyperbola like this. Here, they'll actually go here and trace this out and draw it like that. So that's bad. Okay, I don't want that. The other thing that I'll see is people, as far as the asymptote is concerned, they'll draw to the asymptote, but then they'll ricochet as if it's a pool table. Well, that's not so good either. The last major error that I see in terms of people graphing this is that they'll treat this as if it's the vertex and draw it out like that. So hopefully avoid some of these errors because that will kind of take away from your score. You know, just get close to this. If you accidentally touch it, I'm not really going to worry about it. Just don't cross through it egregiously. Let's try problem number 18, unless there's some further thoughts or comments on 14. Yes?
Can you slide the paper up the other one? I just want to see if the x is greater than 0.
Okay, yeah, so it's basically it's saying if this term is the positive term, you know, you have a positive x squared term, then it's going to open left and right. If you had a y squared term that was out in front, you know, some y squared term minus the x squared term, then it's going to open up and down. Okay, so let's take a look at what our next problem is going to be then. All right, I think we're going to have to stick with what we have on the handout. So it's not going to be problem number 18, but we'll work with it anyways. X squared minus 2y squared equals 3. Similar to the way we worked our way through section 11.2, we're going to do the same thing here, and that is, let's start this by getting a 1 on the right-hand side. So I'll divide everything through by 3. And I get something like this. I still have to play around with that right-hand side a little bit. So, or how about the other right-hand side? How about the left-hand side? I'll write this as square root of 3 squared. And this one is going to need a lot of love. I'll write that as y squared over something. What would I do to get that 2 down here? Yeah, the reciprocal. So 3 halves. But it's not squared yet. So x squared over square root of 3 squared minus y squared over square root of 3 halves squared equals 1. Why did I do that? Well, I wanted to put it in that standard form. Not a bad idea to take a minute and find some square roots. Square root of 3 is about 1.732, or about 1.7 is close enough. Square root of 3 over 2, I don't have that one off the top of my head, although I'm guessing it's 1.2 something. Cool, thank you. All right, so we'll just say that's about 1.2. Now for your convenience, I've put a couple little dots on the handout here. And they're the proper distance. So the first one is going to be at the point square root of 3 and 0. And then negative square root of 3 and 0. And then some in the y direction at a distance of square root of 3 halves. So 0 and square root of 3 halves. And 0 and negative square root of 3 halves. So the game here is to play connect the dots. And I think this is the last one for which I have the diagonal. Well, it's not the last one. But don't expect the diagonals to be drawn on the exam. I do that in class because I want to save you some time in writing. It also helps to make your notes a little bit neater. So if you're looking back at your notes and trying to learn from them, it should be a little bit easier to follow along. Taisha, which direction is this going to open? Left or right or up and down? So we'll base it off of this right here. Which way is that going to open? Yeah. The x squared term is the positive one, the y squared term is the negative one. But if the x squared term is positive, it's going to open left and right. So it's going to look like this. Something like that. And then, draw this one. There. One last thing to take care of, and that's to figure out what's the foci. So in this case, c squared equals a squared plus b squared. Doesn't matter really which order you think a and b are in. You're going to get square root of 3 squared plus square root of 3 halves squared. So 3 plus 3 over 2 is going to be 4.5 or 9 halves. So c will be the square root plus or minus the square root of 9 over 2. And again, I'm not going to badger you into rewriting that in a nice compact form. It can be written as 3 square roots of 2 over 2. That's probably how you'd see an answer in like WebAssign or in the back of your book. But, yeah. So, I'm guessing about 2.1 here. Square root of 9 halves. Katie, you on that one?
Yeah,
2. Oh, woohoo! Yeah, give it up, give it up. All right, so 2.1. 2.1. So, square root of 9 halves and 0, and negative square root of 9 halves and 0. And those are your foci. Now, let's be clear about something here. The reason I calculated square root of 9 halves as about 2.1 is to know where to place this on the x-axis. But when I ask you on the test, where are the foci, I want the exact answers. I want square root of 9 over 2 and negative square root of 9 over 2. Or you can just do the plus or minus game. But either way, I want the exact answers, not the decimal values.
Just 3 over the square root of 2 instead of 3 square root of 2 over 2? Or,
No, I stand by that. Okay. Let's do a couple more. And I got to be careful here. I think, like I said, I was looking at the wrong book when I was writing the notes here. Let's work one in kind of like a backwards direction, much like we did with some of our work in ellipses. And we'll start with problem number 28. So they're giving you the graph, and they want the corresponding equation of the hyperbola. So there's a couple things we can think of, a couple different models we've got. Let me write them down for you quick, and then I'll poll you as to which one you think works. So let me give you two choices here. Which of these two models, x squared over a squared minus y squared over b squared equals 1, or the other one, we'll call this 1 or 2, which one do you think is going to work for problem number 28? 2. Yeah. You have to have something with a positive y squared term here because this one opens up and down. And so, okay, that's a little bit of a start. One of these things we know, and it's not very clear, but you have a vertex at the point 0, 12. So that's telling you the number underneath here. That's a 12. So we can start out our model by saying, all right, well, it's y squared over 12 squared minus x squared over b squared equals 1. That's how we're going to start things out. Now there's another piece of information that they give you, and that is you have a focus at, 0 and 13. And I'm not bothering to show the picture because it's really tiny. They really crammed it in there. So we have a focus at 0, 13, but that gives us some more information that's going to allow us to solve for B. How are we going to solve for B? Perfect. C squared equals a squared plus b squared. So we know that 13 squared equals, 169. Thank you. 169 plus equals 144 plus b squared. So isn't this special? What does b equal?
5.
Good. B equals 5. You don't necessarily have to put plus or minus 5 because we're just going to put a 5 in the denominator. Overall, our equation is y squared over 12 squared minus x squared over 5 squared equals 1. So that would be your final answer here.
Do you want us to also write out the asymptotes or the equation for them?
That is one last aspect of this graph that we're going to look at, and that is the equations of these asymptotes. So yeah, don't get mad at them, Rebecca. It's not something I was going to overlook. It's kind of a major feature of the graph of a hyperbola. So, all right. Don't worry, Justin. Lucas, we'll get you a guard on the way out to the parking lot.
We parked like 5 cars.
Are you okay with problem 28? Looking good on that one? So, all right, since it was brought up, let's talk about it a little bit and see what we can figure out. I think it's on page, it's one of these, I don't trust my notes now. Just find it in here. Here we go. So these equations, or excuse me, these hyperbolas have asymptotes with very predictable equations. So y equals plus or minus b over a times x is the equation of this line. That's in the case where you have a hyperbola in this shape. X squared over a squared minus y squared over b squared equals 1. If you flip things around, and all they're doing is they're flipping around the x and y's, then you're going to get a different set of asymptotes. And instead of b over a, instead of the b coordinate over the a coordinate, you're going to have the a coordinate over the b coordinate, or denominator of y over the denominator of b. So it has some very predictable equations, and let's see if we can't use those things to our advantage. In fact, before we do that, let's double check ourselves on problem number 14, or what I called problem number 14. was actually problem number 17. Let's see if we can't find the equation of this line. Now what I would suggest is that we think of it in this form, y equals mx. Usually I do y equals mx plus b, but what's the value of b for this line? Does anyone know what b is in the form y equals mx plus b?
It's the intercept.
Yeah, b is the y-intercept, so b would be 0. So let's do a little Photoshop and get rid of that then, right? We don't need that. It's just y equals mx. All right, so what's the slope? Well, you might remember slope is the rise over the run. So let's start out at the origin, and I'll move over 2 and up by how many? Not 12. 1, 2, 1, 2, 3. Over 2 and up 3. So in terms of the rise over the run, we get 3 halves, and my equation is y equals 3 halves x. So that's the equation of this asymptote. Let's compare that to what the book says. So in terms of comparing it to what the book says, there's 2 different possible types of equations. One where the x squared term is positive, one where the y squared term is positive. In our particular example, we had this one. So you're going to get an asymptote. Move this up a little bit. You're going to get an asymptote of this form, plus or minus b over a, which is going to be the number b from underneath the y coordinate, or the y term, divided by the number a. Let's check that out. The equation for this hyperbola was x squared over 2 squared minus y squared over 3 squared equals 1. So if I divide 3 by 2, that gives me my slope. Now realistically, there's 2 possibilities. There's the positive one or the negative one. So the other one, its twin, is negative 3 halves x. And that's just the other line here. There is a shortcut that I have in coming up with the equations. And I can justify it to myself. It's nothing that I would take the time to justify here. But let me show you that, and you tell me if you like it. If you don't like it, it's fine. So if you wanted to find the equation of the asymptotes, and you're given the equation. So we're given x squared over 2 squared minus y squared over 3 squared equals 1. To find the equation of the asymptotes, and this is a little bit of a cheat, I'm going to write it as x squared over 4 minus y squared over 9 equals 0. Which, you're like, well, wait a minute, where's the 0 coming? Well, it's just something I figured out that works. And we're going to solve for y. So I'll move the y squared term to the other side. And then I'll multiply both sides by 9. So I get 9 x squared over 4 equals y squared. Well, I'm still trying to solve for y. What can I do to solve for y? Square root. And it's plus or minus the square root, right? Yeah, and this simplifies, all of it simplifies. 3x over 2 for y. So, ta-da. It works. You don't have to use it. It's convenient if you do use it, but you don't have to use it. All right. No big hurrah from the bleacher seats, so I'm thinking that maybe you don't like that one, but 12. is it worth it to spend a moment figuring out how to graph these on a graphing calculator?
I'm curious.
Okay. Let's take a look at problem number 36. And this kind of skill can help you out a little bit in terms of graphing it, graphing ellipses as well, because the stuff that we do here will apply directly to ellipses. So problem 36 gives you x squared over 100 minus y squared over 64 equals 1. If I want to graph this on a calculator, what do I need to have by itself? I need to have y by itself. So let me do this to start with. I'm going to move the y squared term over here and the 1 over here. So I get x squared over 100 minus 1 equals y squared over 64. Now I want to continue to solve for y. What could I do next? What should I do next? Thank you. Multiply both sides by 64. I get 64 x squared over 100 minus 64 equals y squared. And then I'll take the square root. Square root of 64x squared over 100 minus 64, actually plus or minus of that, equals y. So you have to program in two different possible equations. You have to program the positive root and the negative root. So let's see how that's going to work. And again, I'm going to show you a little bit of a trick in at least doing part of this. So hit the y equals key, and let's get started. We want the square root of all this, 64x squared over 100, and then minus 64. Now, it's up to you. I will type it all out exactly. You could actually type in 0.64 x squared, but let me type in 64 x squared divided by 100 minus 64. I don't need any parentheses here. None whatsoever. Now I could type in this all again, except I got to type in a minus sign out in front, right? That's too much work. So here's the trick. This is on the back of your parabola handout as well. I just need to type in the opposite of y1. So let's do that. Type in the negative key, opposite key, and then follow along. Opposite key, then hit the vars key. And it gives you a bunch of choices. Cursor over to the right, y vars. Press enter, and then enter again. So there you go. Ooh, just the opposite of y1, right? Cool. So now you could type in negative and then repeat that square root again. But yeah, here's a little trick for you. Do you like that trick? Good one? Yes? All right, cool. Now let's figure out where we're going to view this, set up our viewing window. And for that, I want to look back at this problem, at least initially. You know, if I was graphing this, I need to go to the left 10 and to the right 10 along the x-axis. I need to go up 8 and down 8 on the y-axis. So I better have a window that's big enough to see that. It's not enough just to go from negative 10 to 10 and negative 8 to 8. So as far as my window is concerned, let me go a little bit farther than that. Let's go out to negative 15 to 15 on the x-axis, and let's go negative 11 to 11 on the y-axis. And these are just guesses. You can modify them. If you don't like the look of your graph, you can change it. So there's the first branch. And there's a second branch. Yay, there's your hyperbola. It's not going to draw on all that cool stuff that we draw. It'd be a lot more work than I would ever want to do to make it do that. But there's your hyperbola. Any questions on graphing this? I mean, more and more I'm moving away from doing things by hand and asking you to do things on a calculator. So don't be surprised if I ask you to do some things on a calculator. Let's take a look at problem number 42. We've got vertices at 0 and plus or minus 6. And asymptotes at y equals plus or minus 1/3 x. So we've got vertice here and here, 0, 6, and 0, -6. And then we've got some asymptotes, kind of shallow ones. And I'm just guessing, I'm not trying to draw anything terribly accurate. So we have one at y equals 1/3 x and another one at y equals -1/3 x. So the question is, what's the equation of the hyperbola? Two choices here. Which one's correct? The first one or the second one? Second one. This one's going to open left and right. Our hyperbola has to open up and down, so it has to be the second one. And in fact, once we know that it's the second one, we can fill in one of these things, right? What can I fill in? John? Is there anything I can fill in? Katie, some help? All right, good. So the number underneath the y is a 6, because that's just distance right here. That's your a. So I'll have 6 squared b squared. And now we can use that little trick that I taught you just a minute ago. Because we know what a is, if I want to find the equation of the asymptote, let's put in a 0 here for just a moment. Y squared over 6 squared minus x squared over b squared equals 0. And let's solve for y. That's going to be y squared over 6 squared equals x squared over b squared. I'll multiply both sides by 6 squared and get y squared equals 6 squared x squared over b squared. Almost done. If I take the square root on both sides, and obviously it's plus or minus square root on the right hand side, what will I get? 6x over b. Plus or minus 6x over b. But that's really helpful because that means that the coefficient here, 6 over b, has to be equal to 1 over 3. Because that's the coefficient of my slope here. So what does b equal? Good, you just get that from cross multiplying. B equals 18. Ta-da. So, be a very wide hyperbola. Overall, your hyperbola would look like this. Y squared over 6 squared minus x squared over 18 squared equals 1. Now, there is a way to, in the book, I mean, but it takes a lot of keeping track of. To memorize the G, the formula is going to be A over B. In this case, you want to compare A over B to 1 over 3. I don't know. I think this is a little bit cleaner, but it's up to you. For homework, try 5 through 29. We'll do 5 through 27. Just give you one to graph on your calculator. 5 through 27, and let's see, 37 through 45, and only one asymptote problem to deal with. So this is section 11.3.